Okay, pre-calculus final exam review part 6. I'm looking at number 36. If $8,000 is deposited in an account for 20 years, earning 4% interest compounded quarterly, what amount will be in the account? So again, you have to read this. Don't skip over that. This doesn't say continuously. If it doesn't say compounded continuously, then you're using this formula. A equals P times 1 plus R over N to the NT. Now, P is still your principal, A is still your end amount, R is still your rate. So let's identify what we have. If $8,000 is deposited, so that's what you start with. That's your P value. 20 years is your time. 4% is not your rate. Remember, the decimal is after the 4, and you have to move it 2 decimal places, so it's actually 0.04. Okay, that's a point and not a negative. It just doesn't like when I do points. And what is this quarterly, or this N value? Well, that's quarterly tells me that my N value is going to equal 4, because how many quarters are in 1 year? 4. So all I have to do is plug this in. A equals P, which is 8,000, times 1 plus R, which is 0.04, over N, which is 4, to the 4 times T, which is 20. And at this point, on the right-hand side, it's all the numbers. So I'm going to go ahead and plug this in my calculator. 8,000 times parentheses 1 plus 0.04 over 4 to the 4 times 20 power, which tells you that in the end, your A value would equal $17,733.72. And I knew to stop after 2 decimals because we're dealing with money, and our money system only goes to 2 decimal places. 37. We just started learning about this, so this may be a bit of a review for some of you and something sort of new. If point P is rotated 5 pi over 4 radians, give the letter that best fits the terminal side. So what I would do is I would just kind of draw in here my 4 important pieces, remembering now I'm in radians. So this is 0. Remember, this is pi over 2, or 0.5 pi. This is pi. The one down here is 3 pi over 2. Let's start that over. Down there is 3 pi over 2, which is 1.5 pi. And all the way around the circle is 2 pi. And let me rewrite that, because that is just too messy for me. 3 pi over 2. Okay. So I have 5 pi over 4, and it's positive, so I know I'm rotating up and around in a counterclockwise rotation. So I usually like to look, first of all, is this bigger or smaller than 1? So when I look at 5 pi over 4, remember I told you if the top number is bigger than the bottom, that means it's more than 1. If the top number is less than the bottom, then it's less than 1. So I have more than 1 because my top number is bigger than the bottom. The only number on here that is more than 1 and not fully at 2 pi, A would be at pi over 2, B is somewhere greater than half pi and full pi. D is my only option here. D is between 1 pi and 3 over 2, which is 1.5 pi. So it has to, I think that cut off, but again, I was bigger than 1, but I'm less than 1.5, so I'm somewhere in the 3rd quadrant, and the only letter there is D. Moving on to the next page, pause if you need to write anything down. Okay, let's look at number 38. It says, find the inverse of function f of x equals 14x plus 7. We learned this early on in the semester. The first thing I'm going to advise you to do is change f of x to y. And by the way, this is number 38. So change f of x to y. So I have y equals 14x plus 7. And when you find the inverse, all you're doing is switching your x and y values. So, excuse me, I'm literally going to switch them out. I don't move anything else. So where y was, I write x, and where x was, I write y. Now, you have to solve for y. So I'm going to go ahead and subtract 7 on each side, and I get x minus 7 equals 14y. And then I'm going to divide everything through by 14. And you're left with x over 14, reduce this one, 7 over 14, which is 1/2, minus 1/2 equals y. In reality, that y, I should replace it with, I'm going to erase y, and replace it with f inverse of x, and that's what that looks like. So your answer for 38 is x over 14 minus 1/2 equals the inverse of x. Okay, 39 we haven't learned about, but I think I can explain it pretty quickly. When they're talking about a reference angle, they're talking about the unit circle. Okay, so I'm going to draw it out very quickly. My important key pieces, and notice I'm in degrees. So I have 0, 90, 180, 270, and 360. And I've said you should probably memorize all those. And so the reference angle is simply the angle made with the x-axis. And the key is you have to find the closest point. So you have to decide, am I closer to 180 or 360? So let's look where 325 would be. It's positive. So again, I'm going in that counterclockwise motion. So that means I'm going up and around. Is it bigger than 90? Yes. Is it bigger than 180? Yes. Is it bigger than 270? Yes. Is it going to be bigger than 360? No. So it's somewhere in the fourth quadrant. So it starts here, and it comes all the way around to someplace here. Okay? Now I know that this all the way around is 325 degrees. But when they ask for the reference angle, what they're really asking for is, what is this angle right in here? Let me make it a little bit smaller so I can get in there. What is this angle right here, made with the x-axis? Well, all the way around a circle is 360, and I didn't quite make it. I was short of that, so I have to take away the 325, and it will tell me what was left in between the two. So 360 minus 325 is 35 degrees. So the reference angle, or the angle made with the x-axis, is 35 degrees. Because if you combine the black portion that I went around and the blue portion, together they had to make 360. Number 40. Find two angles, one positive and one negative, that are coterminal to 5 pi over 6. If you remember me in class being goofy, I was swinging my arms around and around because I showed you I could go around multiple times but still stop at the same point in the unit circle. Okay, so coterminal is when you make full rotations in either the positive or negative direction, but you still end up at the same spot. So let me show you an example. If I start here and I go here, okay, so if my angle originally went like this, let's just call this 110 degrees. Okay, we'll call that 110. What if I changed this, and now watch if I did this. What if I went around once and came back around? So I'm going to highlight for you where they overlap. Okay, watch this. See, they overlap right in here where I've kind of shaded it in green. And when you overlap those, you can see in gray what's left is a full rotation. So you can find it. I did it in degrees because we often think in degrees, but a full rotation in degrees is 360. In pi, or radians, not pi, excuse me, in radians it's 2 pi. So they want one negative and one positive. So the first thing I'm going to do is do 5 pi over 6 and add a full rotation, which is 2 pi. Now when you go to put this in your calculator, please pay attention here, because I've had several people ask in class, and it's important you understand this. What you're putting in is only 5/6 plus 2. You are not putting pi in your calculator. Okay? Let me repeat that. You are not putting pi in your calculator. Okay? When you do this, you end up with, hang tight here, 17 pi over 6. So the calculator is going to give you 17 over 6, and you have to remember to put pi back in. How do I find a negative angle? Go back to the original angle, which is 5 pi over 6, and now subtract 2 pi. Again, I'm putting only 5/6 minus 2 in the actual calculator. And when you do that, you're left with negative 7 pi over 6. Well, they give you in the calculator negative 7 over 6, and you have to remember to add the pi in. That's it for this video. More to come.